6.9, last subchapter of this nightmare chapter. We're going to make it through it. Modeling with polynomial functions. This is probably, again, one of your favorite ones because most of it is just work by hand or that's simple, or with a calculator that is simple. The first things first is if they give you a graph, which is example 1 in page 380, and they say write the cubic function that matches this graph. The easy way to do this is they're always going to give you the points that you need, right? So I look at that graph and I look that it has 3 zeros, right? I have this 0, and this 0, right? So I know this is a cubic function already. Why do I know that? I have 3 solutions, right? That makes it the third power. All I have to write it is in the right shape. I don't know my Libby coefficient yet, so I'm going to put A. But I know all of my zeros. I can do this. X plus 3. When I plug it in, I change its sign. X minus 2, X minus 5. Okay, I know this. The only thing that I'm missing is that A. If I find that A, I am gold. So how do I find that A? Well, if you notice, they give us an extra point. They give us a negative 15 and 0, which means when x is negative 15, y is 0. I can take that and plug them in here, this for y, so 0 for y, negative 15 for x, and get my a out. 0 equals a times. Let me look at this. This I wrote bad. This is 0 and negative 15. That's why I was like, this is not right. Negative 15 equals 0 plus 3, 0 minus 2, 0 minus 5, right? I put the y instead of f of x, and I put the 0 instead of all the x's. This becomes negative 15 equals a times 3 times negative 2, negative 6, times negative 5 times 30. I divide the 30 out. A is negative 15 over 30, or negative 1 over 2. I take this and I put it in here, and you're done. The greatest news about this, you don't actually have to open those parentheses and find that stuff out. So when you have to find the function given to you, you're going to look at the number of solutions. If it's a 3, it's a cubic function, I'm going to have 3 parentheses. If I only have 2, I'm going to have 2 parentheses. Keep in mind that they can give you something like this. You're going to say, well, it's only 1, I have 1 parenthesis. No, that's a quadratic. If it touches that and it changes direction at negative 3, let's say that is x, 3, sorry, minus 3 and another x minus 3. Why? At that point, it changed direction. That makes that a double solution, okay? But you plug it in, and then they will always give you an extra point. You're going to put the y instead of the f of x right there, the 0 instead of your x's, and get your a out, and you get your functions out. Now, example 2 and 3 deal with something that I am not going to teach you to do it the way the book is teaching you, because it's too much work and it's not going to take you anywhere other than wanting to shoot yourself. It did that to me. Okay, so they're talking about finding finite differences and then modeling with finite differences. Now, if I would have to figure out the finite differences, it will take me quite a bit, right? If you look at that and it tells me a formula for the nth regular number is f of n is 1/2 n squared plus n. F of n equals 1 over 2 n squared plus n. Okay, and now I want to know, I'm going to find the first 7 terms. What is f of 1? What is f of 2? What is f of 3? What is f of 4? What is f of 5? What is f of 6? And what is f of 7? Well, if I put 1 in there, this becomes 1 plus 1, 2. This is 1. If I put 2 in there, it becomes 6, it becomes 3. If I put 3 in there, 12 divided by 2 is 6. If I put 4 in there, 13 divided by 2 would be 9. I might know half of 16 plus 4, half of 20 is 10. 5, 25, 30, half of 30 is 15. 36, 42, half of 42 is 21. And 7, 49 plus 7 gives me 56. Half of 56 is 28. Is that right? Yes. Okay. This is my first thing. Now I'm going to go ahead and do the difference in between them. What is 3 minus 1? 2. What is 6 minus 3? 3. What is 10 minus 6? 4. 15 minus 10? 5. 21 minus 15? 6. 28 minus 21? 7. And then I'm going to do another difference. 3 minus 1. 4 minus 3? 1. 5 minus 4? 1. 6 minus 5? 1. 7 minus 6? 1. So I went through second orders, and my second row of orders, I got all ones. So this is called, the way you will write it down, it says show that function has a constant second order difference. By the time I got to the second difference of the things, I got a 1. For your homework, they'll give you the function. You will have to do this for example 2. That is fine. You're going to find the first 7 terms, and then you're going to start subtracting it until you see where you get, and that should be the second order, the third order, wherever they ask you to improve. Okay, that's very, very easy enough. Now, for example 3, we're not going to do it the way they do. They give you a whole list. If you notice this, you have an f of 1, an f of 2, an f of 3, an f of 4, an f of 5, an f of 6, an f of 7. And please remember this from this perspective. F stands for y, right? So when I have let me pause this so I can put this in my calculator and restart the video. Okay, I'm back. I put my stuff in. If you look example 3, your f of 1, 2, 3, 4, 5, and 6 are going to be your list 1, right? So my L1 in my calculator is going to be 1, 2, 3, 4, 5, 6, and 7. My L2 in my calculator is going to be the values of it. 1, 4, 10, 20, 35, 10, 20, 35, 56, 84. Okay? And now I'm going to want to know what is the polynomial function for this, okay? First of all, they want to know what is the polynomial function that does that. The one thing you will have to do is find out what degree that polynomial has. So, here's what I do know. I'm going to go f of 1 to 7. So I get 1, 4, 10, 20, 35, 56, and 84. I need to know my first difference. 3, 6, 10, 15. Lordy, I don't know. I'm going to copy in the book. 21 and 28. Definitely not the first degree polynomial because these are not all 1. Let me do the second one. 3, 4, 5, 6, 7. If you're wondering what I'm coming, this 6 minus 3, 3, 10 minus 6, 4, 15 minus 10, 5, 21 minus 15, 6, 28 minus 21, 7. Definitely not a third degree polynomial because that's my first, that's my second. Not a third degree because I don't have ones. No, not a first degree, not a second degree. I already know it's going to be a third degree, right? I am now having this on the first, second, third degree. So I'm looking for a cubic function. This tells me this is a cubic function. Okay. If I would have had all 1 here, this would have been a linear. If all my 1s would have been here, this would have been a quadratic. Okay. That's just how I know. Now that I got this, I'm going to go to stats. Remember our friend in stats? I'm going to go to edit. I'm going to hit enter. And I'm going to put for my list 1, those numbers. For my list 2, the other numbers. So for my list 1 is everything that's with the F. 1, 2, 3, 4, 5, 6, and 7. For my list 2 is whatever that each one of them have correspondent to it, right? Again, remember, not a linear, not a quad, a cubic, because that's where I got all my ones. I'm going to go back to stats. I'm going to go over to calc. And for your cubic, you're going to look at this, and option 6 says cubic reg. I'm going to go to 6. I'm going to hit enter. I'm going to say, yes, I want to do that. And here's my A. And you're going to see how we wing this. A is 0.1666667. B is 0.5. And C is 0.33333. If I have to write this as a fraction, this becomes 1 over 6. How do I know this? Well, there's 2 ways to do this. I go 0.166666667. If I go 1 divided by 6, that's what I get. So it's 1/6. And then 0.5 is 1 over 2. And 0.333 is 1 over 3. These are fractions that we should be familiar with. So my cubic function is 1 over 6 x to the third plus 0.5 x to the second. I lost all of my information. Is that terrible? Not 0.5, but plus 1 over 2 plus 1 over 3x. And I should have a number there. I should have a d, right? Because it's a cubic function. I do not have one, so it would be plus 0 or nothing. That's where we are. Generally, if we have another one, it would be a d. They will give us the d in the line, but in this case, we didn't have one. And this is my cubic function. How did we do this? List 1, list 2, stats, over to calc, go to option 6, which is cubic reg, and get your value out. If you flip your page to 382, we have one last word problem to deal with. I'm going to go ahead and pause the video for a second and put my list in and come right back. Okay, all of my information is put in my calculator. If we look at that boating problem that you have here, it tells you have the average speed y in knots of the boat versus the different engine speeds x that you can put on that boat, different engines that what they give you, okay? And they want to know first, find the polynomial model for the data. Here's the great news. This is good for you to remember. I told you this in class also. Every single word problem you're going to deal with in this chapter will be a cubic problem. So you don't ever have to worry about it. You're doing a cubic. You don't have to guess. You don't have to worry about it. Please remember that. So what do? I go to stats. I do edit. I hit enter. And I already put my list 1 and list 2 in there, so I don't keep you in there. I get it 1 first. I put the second one up there. Then I go back to stats, move over to calc, and I'm going down to option 6. I hit enter, and I'm going to tell it, yes, please give me this function. And here it is. My A is, I'm going to write this down really fast. A is 0.0048, sorry. How many decimals do they use in the book? Okay. 7.515 decimals. My B is negative 0.1943. I'm going to use, they're very not consistent in this. My C is 3.13. And my D is negative 9.53. I don't know how many decimals tell you that to keep. I would just write it like this. Okay, that's what I would do. Whatever. So now I can write my function. F of x equals, I know it's cubic, 0.0048x to the third minus 0.9194x to the second plus 3.13x minus 9.53. There's my model. It's given to me by the calculator. I don't have to do squat, right? That is my cubic thing. Then it says estimate the average speed of the Trident for an engine speed that has an x of 2400. All you have to do, keep in mind that your x is already in hundreds, which means what is f of x when x is 24? So you put 24 here, 24 here, 24 here. This is to the third, this is the second. You plug that in the calculator. I'm not going to do it now. We're going to waste time, okay? Do it correctly. Go ahead and put this times 24 to the third plus minus this times 24 to the second plus this times 24 minus this. You just plug it in the whole thing in one move. And the answer to that question was 19.51. This is just calculator work, okay? For 0.3, it says what engine speed produces a boat speed of 14 knots. This is a different story because I tell you now, my y is 14. What is my x? And we cannot do this by doing math on this. We're going to go bananas. But what we can do is go in here and graph this function. 0.0048 x to the third minus 0.194 x to the second plus 3.13x minus 9.53. I plug all this in here. Remember, this is a real life situation, correct? I need a real life situation. My x minimum is 0, my x maximum. I'm looking at my x's and they're going over 21. So I'm going to make my x maximum, I don't know, 30, just for the sake of it. My y minimum, again, you can't go negative speed, so it's going to be 0. My y maximum, they already told me that my y will be 14. So I'm going to make my y maximum 16 just for the sake of it. I'm going to graph this function. Here's my graph. Okay, there's my function. I'm looking for what is x when y is 14. So this is going to go to trace. And I'm going to look, my y right now is 9.97. I want my y to be as close as I can get it to 14. When I get there, here it is. I get 13.99 something. My x is 20.1 or approximately to 1. Approximately, yeah, because I rounded my thing too differently. My x is about approximately 2,000 RPMs. Okay, I just pulled it out. It's 20.10. This is in hundreds, so it could be 2010. Remember, I'm using this. They had in here a 7.5. Believe it or not, that makes a lot of difference. I couldn't care less. I will give you credit for whatever you use on this. But again, a lot of calculator work, not hard. Remember, using trace, when you know your y, you just keep using until you get to a y where you need to be to get your x. Remember your stats. And remember that under your chapter 6, you have a few sheets attached there. One of them is how to use a calculator to graph different models. If you look on the bottom of that sheet that I also gave you in class, you're looking for chapter 6. Ignore chapter 2, chapter 5, and whatever comes next. You're just looking at instruction for chapter 6. And we're done. Happy homework.